Alright, so hi, my name is Brent. I'm a rising senior at Public High School. My starter project, I built a Minty Boost, which is called a Minty Boost, no actually. It's actually a little phone charger, but it's contained within a little mini can. So if you're all wondering why it's called that, really nice, convenient way to charge your phone. And for my main utensil project, I built a hovercraft. See, it's not easy to control, but that's inherently in design. Now, my hovercraft is it's a vehicle that uses an air cushion to rise off the ground, and that causes it to reduce friction with whatever surface it's traveling. Why is that important? Because that means it can travel across a bunch of different surfaces. It can travel over water, it can travel over land, and that's why in industry and in the real world it's used for things like military landing troops, or landing supplies, or for humanitarian missions, or simply as a ferry in some parts of the world where a boat would be useful. A hovercraft is far more useful because it can operate without an extensive port. It can just go up onto the sand and drop people and other things. Wonderful design. So my hovercraft is composed of 3 layers of special foam called Depron. Depron is a very, very light foam, but that makes it very useful for this project because that means it can rise off the ground. It uses 2 fans. It uses a lift fan, 64 millimeters. So these fans, they look a lot like jet engines. That's because they are. They're electric ducted fans. They're controlled using ESCs. ESCs are electronic speed controllers. These fans are DC motors, but they're different from other DC motors that simply need to be connected to a power source. They have a signal too, because they can be adjusted during the method. That's why I can control it using this. All the motors are connected to a receiver, and that receiver allows me to control everything on here, including the 2 motors and the servo motor. Use the servo motor because I want to use thrust vectoring. Now, thrust vectoring you see on a lot of military jets. The F-22 uses thrust vectoring that allows them to move very quickly, and the same goes for this. Some people use fins and they're able to direct the thrust differently. Me, I just change the direction of the fan. Why? Because that's more efficient, in my opinion. It allows you to quickly move and it allows you to make turns on a dime. I can literally spin this in a circle just using the thrust vectoring alone. The lift fan is very powerful. I only keep it on the lowest setting. Why? Because this is it's so powerful that if I were to put it on the highest setting, it would actually cause the foam to bend. That was one of the challenges I faced. See, this foam, while being very light, it's not the most structurally sound material, and because of that, it would start to bend at higher speeds, or higher RPMs with its fan. So I have to keep it on a low setting, and I had to reinforce it with tape. Now, I also had problems with 3D printing. 3D printers, they're beautiful devices, but when they don't work, they're evil. And the reason I say that is because if you see this lovely Halloween-themed piece right here, it's nice and angular over here, but then over here it's curved. And why is that? It's called warping. On a 3D printer, the way it works is it puts melted plastic onto a piece of metal, and over time it cools. If you have a large flat surface, it doesn't cool evenly, so it doesn't work. It starts to change its shape. Now, in Blue Stamp, I think the most important thing it taught me is perseverance. And that is because when I was building this project, parts would break and time was a vampire. Because Amazon refused to ship things quickly. No Amazon, why? But when it did work, it worked great. And that was because I spent a lot of time getting new parts. Neil helped me a lot trying to find new parts because my original ESCs did not work very well, so I had to replace them. One ESC at one point melted down because it was either built incorrectly or there was another thing wrong with it. We're still not sure, but we were able to fix it, we were able to replace it because we persevered, we went through it. We were able to design everything using CAD software. Every piece you see on here, excluding the wiring, was made using computer-aided drafting. The entire system, building it, designing it, taught me that even in the darkest hour, when you think it's not going to work, and you don't have a lot of days left, because I was only in 3 weeks, full day for 3 weeks, You still have to keep going, you still have to make it work. And so by the end, after many trials and tribulations, I was able to make a functional hover. Questions?
Did you ever have to cut the wires?
Oh, well, let's just say that when one of the ESCs blew up, we had to resort to some interesting tactics, which is literally taking the X-Acto knife and cutting as many wires as we can to get the power to stop flowing to take parts, because we didn't want to lose anything else. That was during one of the first test runs. Luckily, that never happened again.
Alright, so you said those motors you had were really powerful, how fast can you speed?
30,000 RPM. 30,000 RPM, something like that.
We might want to borrow your services when you clean up or flowing.
Yeah, they use these. These are not designed originally for hovercraft. These were designed for model airplanes, really big model airplanes. So it turns out there's a whole subculture of people who put together massive airplanes and use small EDFs like this to power them and fly them through the air. You can look videos on YouTube. It's honestly one of the most incredible things I've seen.
So you said if you run the lift fan too quickly, the Depron will bend.
Yes.
What is it you could run the fan quickly but still kind of provide support to the Depron?
Well, I could change the material, and I could have reinforced the Depron, but honestly I didn't have enough time. However, I think the best way to fix the problem would just simply replace the bottom piece, which isn't necessary to be Depron. I could have used a stronger material in retrospect, and I think that would make the system hover a lot more, and it would reduce the friction a lot.